7 is negative 5, and then put the I back on it, and you got it. Negative 2 minus 5I. The addition ones are easy because we don't have to worry about the signs other than what's there. So let's take one more look at an addition problem, and then we'll move on to some subtraction. Alrighty. So starting with this one, let's look at the real parts. We have a negative 3. Is there anything else that's real that I can join it up with? No. So that 3, the negative 3, is going to be out front. Well, then we've got the imaginary parts to look at. We have a positive 5i and a negative 6i. 5 minus 6 is a negative 1i, or I'm just going to put negative I. So negative 3 minus I. Alrighty, subtraction. So, just like all those other times that we deal with negatives out in front of a parenthesis, we can't just strictly use what's in the parenthesis as it is. The negative out in front of the parenthesis means I have to change all the signs of everything that's inside of it. So I'm going to rewrite this first. I'm going to have 2i I'm going to have 2i, and then the 3 that's positive inside is going to come out as a negative, and then the 5i that's positive comes out as a negative. So we just changed the signs of everything. Now, combining like terms. I've got my real part right here. Is there anything else that's real? No, so that's going to come out front. Now you've got your imaginary. You've got 2i and a negative 5i. So 2 minus 5 is negative 3, and then you put the I back with it. Negative 3 minus 3i. So as long as you remember that with negatives, you got to change all the signs and the stuff to follow, following parentheses, then you'll be okay. Okay, so this one, we have the real parts of 4 and 4. So that's 8. And then notice that you have a 3i and a negative 3i. Well, 3 minus 3 is 0. So the I part it disappears, leaving you for your answer of 8. Okay, so the next slide is not, well, okay, good. I deleted it. On your handout, you have a slide that talks about the coordinate geometry. You can X that out. I don't really worry about the coordinate geometry part. So what we need to go to next is that following slide. It says you can multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Simplify using the fact I squared equals negative 1. Okay, so here we go. Now we're multiplying. We have 2i times 3. Well, that's 3 times 2, or 6. Keep the I with it. And then you've got 2i times a negative 5i. Well, 2 times the negative 5 is negative 10. But then the I and the I become I squared. So here's what happens. I squared becomes negative 1. That's what that last slide just says. So here's what you would have. 6i minus 10 times a negative 1. You've got 6i. What's negative 10 times negative 1? Positive 10. And then last but not least, it wants it in the complex form here, the a plus bi. So you've got to move the 10 to the front and add on that 6i. That's the official answer that they want. So not too bad, as long as you remember that I times I is I squared, and then anytime you have an I squared, it comes out as a -1. So let's try another. Okay, this one's a little bit lengthier, but you can do it. 4 times 6, 24. 4 times -I is -4i. -4i times 6 is -24i. And then -4 times -4i times -I is a positive 4i squared. Now let's combine what we have here. I'm going to start with my i's. -4i minus 24i is a -28i. I'm going to leave the 24 alone for now because I want to take care of this 4i squared. What do we know I squared equals? I squared equals -1. So that's 4 times a -1, or -4. So we have to combine that 24 with a -4, which is then 20. And then we bring down that 28i. So 20 minus 28i. Okay. Now, we're also going to look at operations with complex numbers. So after this slide, we've only got two examples on this, and then 2 examples on something else, and then we'll be done for today. Okay, so notice here, it's kind of giving you a cheat sheet. I to the first power is I. I squared is -1. I to the third becomes -I, and then I to the fourth is going to be 1. So if you look at that, if you can remember I, -1, -1, I, 1, that pattern begins to repeat after that. So 1, 2, 3, 4, and then notice that the next column is 5, 6, 7, 8, and the next column is 9, 10, 11, and 12. So what we like to do here is basically use that I squared to our advantage. So let's give this a shot. We got I, -1, -I, 1. Okay, so I to the 7th. What we do here is we try to figure out, and we factor out that I squared. So this is 1/2 times I squared. But when I pull out I squared, how much is going to be left? Okay, so if you notice I to the 7th is I squared to the third power times I. Well, we know I squared is -1. So -1 to the third power is going to stay negative, and then that I is going to come down. So this is going to be -1/2 I. Okay, so that took into account that third rule there on the left side of my screen. Let's give this next one a shot. Sorry, I kind of screwed that one up a little bit there for a minute. Okay, I to the 42nd power. So what we want to do is we want to take this and break it down. Okay, so I to the 42nd is the same thing as I squared to the 21st power. I squared to the 21st power. So then what you have to do, I squared is negative 1. Negative 1 to the 21st power is going to be what? It's going to stay negative 1. So I to the 42nd is the same thing as negative 1. Alrighty, last but not least, recall that expressions in simplest form cannot have square roots in the denominator. Okay, we haven't dealt much with that yet here, but I'm going to tell you right now, you cannot have square roots in the denominator of a fraction. Okay, so what we've got to do is using the complex conjugate, we can get a square root off the bottom. So, here's our first example. 3 plus 8i all over negative 1, or negative I. So what you do is you take this and you multiply this by the complex conjugate of the bottom. So you've got negative I on the bottom. The complex conjugate of it is a positive I. Okay? But then you have to do that on the top as well. So here's what we do. Negative I times I on the bottom results in negative I squared. And then we have to take the I on top and distribute it to everything on the original. So this becomes 3i plus 8i squared. And now we have to simplify. Well, I squared is negative 1 on the bottom, but then you have that negative already there, so that's just going to become positive 1. Okay, the I squared on top is negative 1, so 8 times negative 1 is negative 8. And then I've got 3i up there still. Okay, so that 1 on the bottom really doesn't mean anything. We just need to put the top part into the actual standard form for complex numbers. So that's going to be negative 8 plus 3i. And if you want to leave the 1 on the bottom, you can. Negative 8 plus 3i all over 1. Last but not least, we have one last example. Okay, 3 minus I all over 2 minus I. So you start by multiplying this thing by the complex conjugate. So the complex conjugate is 2 plus I. That's on top and bottom. Okay, so now it's our job to distribute. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And then negative I times I becomes negative I squared. So I'm going to go ahead and finish that bottom before I worry about the top. 2i minus 2i. That's going to get rid of each other. So then you'll have 4 minus I squared. Well, what's I squared? I squared is negative 1. So you've got 4 minus negative 1, or 4 plus 1, which is 5. Now the top. 3 times 2 is 6. 3 times I, 3i. Negative I times 2, negative 2i. Negative I times I, negative I squared. So we have here, let's combine our i's first, 3i minus 2i. That's going to be just positive I. And then we've got to break this down. I squared. I squared is negative 1. and then you've got that minus in front of it, so it becomes plus. So you have 6 plus a 1, or 7. 7 plus I over 5.